Okay, so this is our new structure. It has chiral centers. So quickly I will identify this as a chiral center because this carbon has 4 different substituents: methyl group, OH, bromine, then the whole of this group. So let's try and assign RNS configuration to each chiral center. So this is a chiral center, this is a chiral center, this is not a chiral center, this is not a chiral center, this is not a chiral center. So we have 3 chiral centers in this structure that we want to assign RNS configuration to. So this has this carbon is a methyl group, and OH, bromine, and the whole of this group. So this bromine will be our number 1 priority in terms of comparing element to element, where there's oxygen and OH. So this will be our number 2 priority. Now this is a carbon, this is a carbon, but this carbon is attached to bromine and other carbons. This carbon is attached to hydrogens. So obviously this side weighs more than this. So this will be our number 3. This will be our number 4. So to assign that, I will have to sketch or redraw the structure in sketch form. So I'm going to sketch something like this and put here, instead of the element, I'm just going to put the numbers around it. So number 4 is our lowest priority, then number 3, and then number 2, and the highest is number 1. So our lowest priority is in the plane. So to assign that, we need it to go either pointing towards us or away from us. So we don't want our lowest priority to go in the plane. So we need to interchange, reshuffle the structure. Okay. So I'm going to interchange 1 and 4. I'm going to put 4 here and I'll put 1 here. Then at the same time I have to interchange 2 and 3. So this will be 3, this will be 2. So my lowest priority now is pointing away from me. Okay. So having that, I can now assign my RNS configuration, and it goes counterclockwise. So that means that this is an S configuration. Okay. Now I can erase smooth. I just drew this to assign the RNS configuration, so I can now erase it. Okay, good. So at this chiral center, this is attached to bromine, and then we have these groups around us, but the hydrogen is not shown. If there's nothing here, it means what is there supposed to be hydrogen. So as soon as you see that, you can quickly draw it, and then this group bromine is pointing at us. So that means that hydrogen is going to point away from us. So anytime you see something like this where the 3rd element or atom is not shown, That means that element is supposed to be hydrogen. That's why it wasn't shown. Now if you look at this carefully, of course the highest priority element which this is attached is bromine. Now we have carbon here, we have carbon here. Which one is higher? Okay. Now you have to look at what is attached to those carbons. This carbon is attached to this carbon, is attached to this carbon. This carbon is attached to bromine, is attached to oxygen. So it means that this carbon is attached to element with higher priority than what is attached to these carbons. So it means that this group will take precedence over this group. So this will be our number 2. And then of course this will be our next one. And then the hydrogen will be just number 4. You don't even need it. You can just ignore it because it's hydrogen. So seeing that we have to go from 1 to 2, so going into that, we have to go clockwise to the right. So that means that this is R. Okay. And then after doing that, I need to clean up the structure. So anytime you see 3 connections where the 4th one is not shown, it means the 4th one is hydrogen. That's why it was ignored. And anytime what is there is pointing either towards you, it means the hydrogen is pointing towards the back, away from you. If what is over there is pointing away from you, it means the hydrogen is pointing at you. And they don't have to show it, you have to know it, or they will assume that you know it. Okay. Now let's try assign awareness to this chiral center. So obviously our hydrogen is pointing away from us because this guy is pointing at us. Okay. We don't need to draw the hydrogen. Okay. So I can just okay. Now let's assign priorities. This is carbon, this is carbon, this is carbon. Okay, so we have 3 carbons. Now we need to look at what is attached to each carbon. This carbon is just attached to 3 hydrogens. This carbon is attached to 2 hydrogens and a carbon right here. So this weighs more than this. Okay, this carbon is attached to bromine. So obviously this whole side is going to take the number 1 priority. And then this carbon is attached to a carbon, take the number 2. Then this carbon is only attached to hydrogens. Okay. So we don't need to show the hydrogens because it will be the lowest priority anyway. So go from 1 to 2. And we are going counterclockwise. So it's this. So that means this side is this. Okay, now we can clean up the structure. All this from here. Okay. So now we have a clean structure that we can use. So I need to determine the harness configuration of the chiral centers here, here, and here. So I'm going to start with this end again. Now over here, this is my number 1, this is my number 2. Now I have carbon and carbon. This carbon is bonded to 2 hydrogens and carbon. This one is bonded to fluorine and carbon. So this carbon is bonded to higher molecular weight. So the twins, so take priority number 3. And this will be my lowest priority. Now my lowest is in the plane. So again I need to sketch and re-sketch it to get my harness configuration. So, and then this is 2, this is 3. Just as it looks here. And then I need to arrange them. In this case I need to change this and this. This will make sure that my lowest is going to the back. Okay, so since I've done that, I can see that from 1 to 2 I'm moving counterclockwise. So this is S. So as I said, be very careful not to jump into conclusion that this is like this. That will give you the wrong answer. Okay, so always, if the lowest priority is in the plane, re-sketch it so that the lowest is pointing away from you. Just as I've done here, I've just changed 2 groups and 2 groups at the same time, and that gave me the proper answer. This will give me the wrong answer. Now when I come to this side right here, I have to clean up this. Okay, over here is my highest priority, and then this is my, obviously my lowest. I have this carbon here. This carbon is bonded to 2 hydrogens, and a carbon. This carbon is bonded to 2 hydrogens and a carbon. So I need to find out what groups are bonded to these carbons that are bonded to these carbons, because this and this are bonded to 2 hydrogens. So I cannot differentiate between them right now in terms of priorities. So I need to go here. This carbon is bonded to this carbon, which is bonded to bromine and chlorine. So obviously this is higher molecular weight. So the twins, number 2, and then this carbon bonded to this carbon. This carbon is bonded to only fluorine and hydrogen. Alright, this whole group will be my number 3. So this is easy since my lowest is pointing away from me, my highest pointing towards me. Can go over 4 and reach 2, and that is counterclockwise. So this is this. So that makes it very easy. Now I'm back to another situation. That is this carbon right here. Over here, this is my number one priority, and this carbon will be my number two because it's bonded to higher molecular weight substituents. So this is my number two, and then this carbon will be number three because it's only bonded to hydrogens. Now, where is my fourth priority? Again, it's hydrogen, but it's not shown. So if this is going away from you, the other group should be pointing towards you. So that is a bold wedge for the hydrogen. So this is for. Now you can go ahead and go over the fourth priority and reach number two. So this is clockwise. This is now because this is going away from me and my lowest is pointing towards me, I have to reverse and make it an S. So this is S configuration. So that's how you assign RNS configuration in this particular case. Okay, I have a different situation now. We're going to talk about Fisher projections. Okay, so assuming you're given this molecule 2-bromopentane, this has a chiral center right here, the bromine, hydrogen, then this group and this group. Okay. Now the representation of the Fisher projection said that the represented in a horizontal line, your chiral carbon is just at the center. It's not shown, and then the other groups are pointing vertical. Okay, so that's how Fisher projections are represented. Okay, now let's see how we assign RNS for Fisher projections. So normally what we've been doing is from the highest priority to the second, then we go over the fourth and then go to the third. Okay, so this, you can see that this is going counterclockwise, which is S. However, the Fisher projection, you have to assign the opposite configuration. So this is going to be an R. Okay, that's how these are assigned. You give them the opposite configuration of what you are normally used to. Okay, this is a mirror image of this structure. Okay, over here the same way, you are going towards the right from bromine to the propyl and go over the hydrogen to the third one. So this is supposed to be R, but for Fisher projections you use the opposite configuration, so this will be an S instead of R. Okay, and then the groups that are vertical, usually those groups, the vertical groups are always pointing away from you. That's how Fisher projections are represented. Again, same thing here, the bromine and hydrogen will be pointing towards you, and then the metal and then the propyl groups will be pointing away from you. Okay, so normally if I'm told to write this, what I would have done is just to, in the previous one, I can just 1, 2, 3, 4, 5, and then okay, 1, 2, 3, 4, 5. Okay, so the bromine will be my highest priority, and then this propyl group will be my next, and then the methyl group will be my third priority. Of course, the hydrogen, I can refuse to draw it. So here you can be sure I'm going this way. So that will be an R. That's what we've been doing. So anytime you're given the name, you can still write the structure by just looking at the chiral center and then try to draw whether the groups are pointing in and out of the chiral center. The rest is easy. And then the same goes for this one. Of course, since I know how this is, I can easily draw 1, 2, 3, 4, 5. So this will be S, of course. It's like here. So R equals S. Of course, my highest priority is pointing away from me. Okay. So normally this is how we do it, but in Fisher projections we have a different method or a different way of doing it.